My presentation is on research, iBUILD research that I carry out with Professor Purnell, and is mostly on the topic of resource-efficient infrastructure. And to get you introduced, I have put together some pictures from around the world. So in the first one, we're looking at an Olympic venue that is left unexploited and abandoned after the games. So it's being eventually degraded because it's no used. And then we have Brooklyn Bridge in New York, which is used by millions of people each year, and yet is aging and needs to be urgently replaced. And then we have demolition of buildings in London because of the need to redevelop that particular area. And all of these show that we generate a vast amount of construction and demolition waste, most of which ends up in landfills like the one we see there in Australia. So in the UK, a staggering 60% of the total solid waste generated is from the construction sector. And this is largely attributed to the fact that most of the resources we used are fixed in infrastructure. So it feels like the construction sector follows a linear way of taking, making, using the resources, and then disposing these resources because they cannot be recovered effectively from the existing infrastructure. And whilst in this past this system was considered to be efficient, a better understanding of the environmental, economic, social, and technical impacts associated with the consumption of resources on the one hand and the disposal of those resources on the other indicates that this model is not viable. So we need to disrupt this linear model in order to enable it to become more circular. And for that purpose, we need interventions at all stages of that particular system. So we've identified through our research that we can have interventions at the extraction and manufacturing of resources by using waste materials in order to produce other components that can be used in the construction sector, or even improving the design of existing components, such as lightweight steel. We can have interventions at the construction stage by promoting a better design that utilizes our resources more efficiently. We can have interventions at the use stage so that we can maintain and repair our existing infrastructure to make it last for longer, because this is another way of reducing the need for putting infrastructure in place. And then we have, of course, interventions at the end of life stage of infrastructure so that we can recover our components and utilize them in a more efficient manner, promoting as such the principles of the circular economy, which requires us to retain our resources in the economy for longer. So from our research, which focused specifically on design and recovery interventions, we found out that from existing infrastructure, we can only deconstruct components. But this can be difficult because of the way these components are fixed into the structures. And even in cases where this is possible, it may not make economic sense. And then we have, of course, adaptive reuse, which is utilizing existing structures or the fabric of existing buildings. But we have, of course, design for reuse and design for deconstruction, which are interventions that can be made at the design stage of new infrastructure, so that we can actually utilize existing components, if there are, and take a whole life consideration of the resources from the design stage of the infrastructure. And of course, we have design for manufacture and assembly, off-site construction of prefabricated components which can be assembled into buildings and other structures, promoting as such a modular design which can enable us to recover those components when the structures reach their end-of-life stage. So these interventions promote resource efficiency. They promote, they enable us to retain the functionality of components used in making this infrastructure in a more efficient way, whilst they are also allowing us to control risks associated with increased resource consumption and volatility in prices, which might be some challenges we may face in the future. Besides the fact that we can retain the functionality of components, we can also bring down energy consumption, greenhouse gas emissions, and life cycle costs associated with the increased use of raw resources, or even with recycling in some cases. And at the same time, we can enable this circular model to promote the development of a new market where component brokers can connect suppliers with buyers. And this can also give rise to the development of new business models, which will be based on trading secondary components or even selling utility and function rather than materials. And of course, there are challenges, and these are many and varied. We have organizational, logistical, technical challenges, but most of these can be overcome if we provide the right regulations and legislations in place so that new business model structures and mechanisms can be developed to support value creation via secondary components reuse. But of course, there are some challenges which are more difficult to overcome. And one of these is related with the information in regards to the residual properties of components recovered from existing structures. How can we know that these components can be matched with new uses? And that's where digitalization comes into the picture. Leveraging the value, the possibilities that smart technologies like components passport promoted by radio frequency identification or even sensors technology can enable us to capture these inherent and residual kind of information we need in order to promote reuse of components. And we need these smart solutions to enable us to track information throughout the component's life cycle. And of course, this is difficult because the highly privatized nature of the infrastructure sector requires short-term benefits, and for digitalization to become more enshrined in our system requires more time, and it also involves some kind of risks. So in conclusion, which of these interventions should we focus on? All. One size does not fit all, and we need to properly implement all of these interventions in order to actually achieve change and transform our currently linear system. Design interventions are better because they enable us to recover components and retain the functionality of these components in the system for longer, or even retain the structures that are still able to be used. Now, digitalization is not a technical solution only. It's also a business opportunity. And if we realize that and we provide the right policy interventions, then the circularity of infrastructure assets could be radically enhanced. And challenges to exist. And the lack of skills is one of those challenges that currently delays the consolidation of improved design and reuse practices. But if the skills are needed, they will be created. The real problem begins with us, all the actors involved in the provision of infrastructure, because we need to change our current mindsets and enable us to take solutions that are more optimal for our system. And of course, we mustn't forget that each intervention has its trade-offs. And these trade-offs can be distributed to the system and affect all actors involved. So when promoting different interventions, we have to be taking into account a multidimensional assessment process, taking into account environmental, economic, technical, social aspects, looking at both upstream effects as well as downstream effects in order to enable our system to perform more optimally and enable us eventually to move a bit closer to sustainability. Thank you.